director of the Resilient Solar Program at Solar One. The Resilient Solar Program is a part of the Here Comes Solar program, which is our technical assistance program, which provides resources to buildings to help them adopt solar and storage technology. So today's pre-bid meeting is for the Stewart's Tenant Corporation, which we'll talk more about in a little bit, but at the top of your screen or somewhere on your screen, you should be able to see my colleagues in this endeavor, Richard and Derek. Say hi. And yeah, we'll be talking about a few things, but they'll be participating and speaking to you as well. So we started working with the folks at Stewart last year, maybe even the year before that, to really determine the feasibility of their building to adopt these types of technologies. They've been interested in this for a long time. They've talked to a bunch of solar installers. They've never gotten the results they wanted. So we worked with them to first evaluate the feasibility of their building, knowing that buildings aren't like theirs aren't like the one that you're seeing right now on your screen. They're in a high rise in New York City, so they're very unique, but they actually have a great opportunity for both solar and storage. So we're really excited to be working with them, and we've done lots of pre-development work to determine what makes sense for them as well. So for the agenda today, we will talk about the various things that you need to submit a successful response to this procurement. And then we'll go over the concept design that we developed, the project deliverables, and the different siting conditions that you should anticipate when designing for this project. So to start it off, we'll talk about the bid. And just 1 second. So this is so for all of you that don't know, we mostly do solar and storage procurement for the Governor's Office of Storm Recovery. This is entirely different and as such, much more easier to respond to. So our other procurements have lots of requirements like bonds and other things that are needed in order to even submit a bid. This is much more simplified. So these 11 things here are the things that you would need to submit a successful bid. Cover letter being super basic. A lot of these things are templated, so solar plus storage system designs, schedule of values, those things are all things we provide, decommissioning plan, energy management, emergency management plan, and qualifications. We try to simplify the process so you can very quickly respond to the administrative side of things while putting a lot of thought into the design of the system that you would be presenting. And now I'll pass it to Derek to talk a little bit more about the actual bid components.
Hey everybody, so we'll start here with design components. So these will include the proposed system designs and all relevant supporting materials. There's a fair bit here, but important to note that everything except for the system drawing itself is available in template format, so it should be a pretty painless process. First, we have the equipment and cost schedule workbook. This is the only item that you will need to submit in Excel format, and you'll also need to submit multiple copies, one for each of the design options. We'll get into a bit more detail about those multiple options later. Here we have the equipment schedule for PV. This gives you a place to provide details for all proposed hardware, mechanical and electrical integration methods, and so on. And as you can see, there are separate sheets for the PV components and the ESS components. Then we also have the cost schedule, where you'll provide costs for all of the components listed in the equipment schedule, plus installation, balance of systems, and indirect costs such as design and engineering, permitting, and so on. Given the complexity of battery installations, we've added fields for other miscellaneous costs on the ESS cost schedule, which you can see at the bottom here. You'll see that the file has been as streamlined as possible when you enter a design option name on the system design sheet, which you can see here at the top. It'll automatically populate that name on the linked schedule of values sheet. So for the ESS, if you name this design option 1, that'll populate at the top here automatically. System size, price per watt, and total costs fields will also automatically populate based on your entries in other fields. And of course, each design option must also include a drawing of the proposed solar and storage system with the locations of all system components clearly indicated. We also ask that you include equipment data sheets, so all available technical specifications plus UL listings as required by the FDNY, and equipment warranties, both manufacturer and workmanship warranties, plus any supporting documentation. Next, we have the energy storage emergency management plan. Here we ask that you thoroughly describe energy storage monitoring, controls, and plans for emergencies such as thermal runaway or remote monitoring failure. Then we have the energy storage decommissioning plan, where you can lay out how the ESS would be decommissioned with distinct plans for what you would do at the end of natural life, as well as after a failure that causes early decommissioning. Some of the questions that we want answered here are: who is responsible for each of these tasks? What are the costs? And what role will the bidder play? Now moving on to the qualifications components of the bid. So these are the basics that we want to see so we can assess your viability as a bidder for this RFP, see what kind of relevant experience you have. So most importantly, we have the vendor qualification form. Here, you must demonstrate your relevant experience and technical competence, including multiple relevant project examples. You can either bid independently or as a team with other complementary vendors, such as a partnership between a solar vendor and a storage vendor. Regardless, each partner must complete all applicable sections of the qualification form. This is just a couple pages long, and again, it's just a fillable form, really easy to finish. Next, I'll hand it back to Angelica to introduce you to the building itself. Uh-oh.
Sorry, Derek and I are sharing control. So it was a little hard to get my mouse back to unmute myself. Before we actually dive into this, I forgot to mention some of the more general things that we're looking for in the solicitation. So we're looking for installers that have done solar and storage, first of all. We know storage is incredibly difficult to implement, but ideally, if you are working on the storage portion of this, you would have built a storage system and solar that has been on a high-rise building, has been in New York City or another dense urban area where similar constraints would be noted. On the PV side, we're looking for vendors that have NYSERDA certification. We're looking for vendors that can really get a project done and have a proven track record of doing so. And that's because this project is in New York City. So you'll see on this slide that this building is right in the center of lower to mid Manhattan, in my favorite neighborhood because of all of the vegan food, right at the border of the East and West villages. It was built in the 1960s. It takes up an entire city block. So there's some commercial offices along Broadway. There's a big courtyard in the back. There's a big driveway in the front where the main entrance is. There's 2 subway lines that abut it. There's a lot going on here. It's a high-rise building, 21 stories. There are elevators. It's not landmarked. It's not in a historic district. So it has all of the right characteristics for a solar and storage installation, minus the complexities associated with buildings of this size. And now I'm going to give it back to Derek to talk about how we came up with our concept design, and then we'll go into more of the different siting conditions at the building.
Yeah, so if you're familiar with our work, you know that we do extensive pre-development for any of the sites that we put out to RFP. And this one was, pretty unique and challenging in all sorts of ways, but we really learned a lot. And I think we've arrived at concept designs that we feel really confident about. And we're confident that we can get a great solar and storage system installed here. So one of the first challenges we had to address was the complex metering situation at the building. So two main questions here. One, we needed to confirm that 1 meter does in fact cover all of the common area loads that would be essential to backup operations, which is really the central goal here of the energy storage portion of this project, providing backup power during blackouts. If these loads were not actually behind 1 PLP meter, the project of electrically isolating all of those critical loads could have been really complicated and potentially expensive. The second question is related to how the PLP panel has been submetered. Bills from the submetering company didn't line up exactly with the Con Ed consumption data that we saw. So to resolve this issue, we deployed our own data acquisition system or data logger on the PLP panel. You can see that on this slide here on the left. This would help us confirm exactly how much power is being consumed by those common area loads. So why deploy this data logger? Well, once we had a month of interval data, we were able to confirm that the submetering was being inaccurately reported, helping to clarify the amount of electricity that is actually consumed by the common area loads. Had we instead relied on just the submetering bills and Con Ed data, we might have significantly underestimated the size of those critical loads. Speaking of those loads, the data logger did help us make sure that all of those critical loads at the building are in fact behind the PLP meter, meaning electrically this would be a relatively simple operation and that we could just power the entire PLP meter during a blackout. Now, what kind of results did we get from this data logger deployment? The building's common area loads consume an average of about 2,000 kilowatt hours per day under normal conditions. To completely meet that daily need during a grid outage, you'd need quite a large battery. So our proposed solution here is not actually to deploy a 2+ megawatt hour battery, since the building is limited in space and budget, but rather to find as good a compromise as possible between the battery's usefulness during backup operations and its cost effectiveness during day-to-day operations. Now, finally, leading into the actual concept design based on all of this information. In this RFP, we include 2 different ESS options, a smaller system and a larger, longer lasting system. The small system is about 650 kilowatt hours nameplate. This could power roughly 25% of that typical daily PLP load of 2,000 kilowatt hours. So for it to last 24 hours during a blackout, the building would need to reduce its usage by 75%. This could include cutting less essential loads such as sewage ejector pumps, running fewer elevators, running them less frequently, turning off some lights, etc. Alternatively, Steward Tenants Corp could use this reserved energy more rapidly to enable a quick evacuation of the building during an emergency. Then next, we have the larger system, which we're calling the medium system, at 1,500 kilowatt hours nameplate. In this case, the battery could power 24 hours of backup operations if the building can achieve a 50% curtailment in typical daily common area consumption. This would require less dramatic load shedding and/or longer backup operations. For both system size options, though, it's important that the PV is able to recharge at least part of the battery during blackouts, helping the building achieve backup usage beyond the battery capacity alone. Next, let's get into a bit more detail on the building itself and some relevant design considerations.
Richard, it's you.
Okay, so you're looking at the ground floor plan for this building. As mentioned, there's a courtyard in the back of the building, which is one of the possible locations for an energy storage system. The other potential location being at the northeast end of the east tower. This northeast part of the east tower is also where the east electrical room is. That's down in the basement, and that's the room that contains the owner's distribution board, which is the panel that we we want to power with the energy storage system. Can we get the next slide, please? Okay, so this is showing the basement, which has a slightly smaller footprint than the above grade portion of the building. We're looking at the east electrical room. If you look at the inset, just to the north of the east electrical room, there's also a gas meter room. I'm pointing that out because there may be some space in this area for to place the automatic transfer switch and other interconnection equipment. Also, the hallway leading into the electrical room is a rather wide hallway and might be a suitable space as well. The electrical room itself is, I would say, fully booked up. You have a large transformer sitting in the middle of the room, and around all the walls you have various meters and distribution gear. So it's not going to be possible to install the automatic transfer switch or likely the dedicated export meter in the electrical room itself. We'll probably have to put it in the hallway outside or in the room just to the north. Can we have the next slide, please? So this is the owner's distribution board opened up. As you can see, it's fairly archaic, but everything is in good working condition. It's a 12208 system. You can see your phases and your neutral coming in at the bottom of this panel. I would assume this would be the tie-in point for the automatic transfer switch. You'd probably have to pull these cables off the lugs, extend them out to the ATS, and then have the ATS output come back to this panel. It's fairly tight working condition, but there is some room available to do the work and to install the additional conduit that you're going to need. So it's going to be a challenge, but we think it's very doable. And I think that'll cover what I have to say about the electrical portion of this for now. I should also mention that this room is roughly vertically located beneath where we would like to put the ESS on the rooftop option. How you get from the roof down to the electrical room is going to be up to you. Yeah, and I'll leave that at that. At the end of this, we're going to take questions via both chat and verbally. A few people have sent me questions, but via chat, we'll try to get to those then. And with that, I'll hand it back to Angelica or Derek.
Thanks, Richard. So as Richard just noted, the ESS can be located in either the rooftop or the courtyard. This diagram shows the two potential locations. The rooftop location was ideal for the FDNY because it's corner of the building, so that you're abutting two streets, which was nice. There's good access there, whereas on other parts of the roof, it's a little bit more difficult to get to. The courtyard option is, you can see that there's a lot of things in the courtyard, so there will be a bit more work to rearrange some things, but overall there's lots of space. There's really good solar access on the rooftop. And yeah, you can see that here. So this is one view of the roof. The roof itself is in decent condition, but before this project is going to move forward, the building is going to have the roof replaced. They're looking at doing that sometime Q1, Q2 of next year, so that you'll be working with a new roof. So anything that is installed, we'll have to make sure the roof warranty is upheld. It's currently a IRMA roof, totally flat with different levels, and there's lots of access points to the various levels of the roof as well. So there are a few different penthouses. There's a water tower inside of this tower over here. There's a lot of different spaces, but again, this is perfect for a mechanically integrated system, which is important for the PV side of things, because we are trying to optimize as many incentives as possible available, since this building is 21 stories and around 225 feet high. In order to get the property tax abatement, you will have to be integrated into the building structure. So ballasted is not an option. I know we incorrectly noted that in the initial email that we sent out, that we meant mechanically integrated. On this view as well, you can see, again, the courtyard that has a few trees. It's a decent size, but it is still pretty close to the building, but there is good sidewalk access. This view of the courtyard is from close to the building. So the fence you're seeing is along the sidewalk over here. This area over here is where they currently keep their trash. So that's where you have some access, as you can see in this photo right here. So courtyard access from sidewalk. So we're looking at this space over here as being the most viable, and that's for a couple of reasons. One being that it's as set far back from the building as possible. There's plenty of space back there. You'd be able to maintain the distances required by zoning and FDNY, and the fence is non-combustible, and it might just be easier. It is worth noting that the courtyard is on top of a parking garage. The parking garage is currently being redone, so it should be able to structurally support the ESS that we're thinking about, and the rooftop should also be able to support it as well. And with that, I will turn it over to Derek, who's going to cover some more about our concept design, and then we're going to take all the questions you have.
Awesome. So yeah, here you can see our helioscope for the concept design. Stuart is seeking an 84 kilowatt PV array on the rooftop, mechanically integrated, plus an energy storage system of either 600 to 800 kilowatt hours or 1200 to 1600 kilowatt hours. We'll get into the distinction between those two designs in a minute. But in broad strokes, the solar and storage system will power critical loads on the common area panel during blackouts. During normal operations, the ESS will be used to optimize the value of solar exports under VDER. Bids should include ESS siting options for both the rooftop and the ground level courtyard, as Angelica mentioned. For the PV system, we ask that bidders maximize PV capacity to the extent that it is permissible, cost effective, and, as Angelica mentioned, can obtain the NYC property tax abatement. Together, the solar and storage system will be connected to a new Con Ed export meter. Community Distributed Generation, or CDG, credits will be applied to the building's existing master metered account. So just a little bit more about this new dedicated CDG meter and why we propose this in our concept design. Most of the battery's capacity will be reserved all of the time for backup operations, so that the moment that a blackout strikes, there's plenty of capacity to serve backup needs. But some of it will be made available to help the PV system optimize exports under VDER during normal operations when the grid is online. We found that the community credit made solar far more valuable as a CDG project than offsetting consumption behind the meter with the solar, and found that by using even a small amount of the battery to optimize exports under capacity alternative 2, we could dramatically increase the value of exported solar. Since our estimates show that this would add more value than would using the battery for behind the meter demand charge reduction, our concept design features a community solar and storage project. A really promising new market in the city that we hope this can be, a real pioneer for setting an example for other projects in the future. Finally, the ESS will automatically connect to the building's PLP panel during blackouts via an automatic transfer switch. The building will then use a mix of automated controls and manual load shedding to manage backup operations, since, as we mentioned, we don't anticipate a battery of the size that could completely cover their typical common area usage. So there will need to be some amount of load shedding. And that is it for the broad strokes of the concept design. I think we're ready to take questions.
Yeah, great. So if you have a question, you are welcome to, you should raise your hand and Richard will unmute you. You can share your video if you want to be more interactive. Please introduce yourself before you ask your question. And then we'll have some more broader introductions later on after a Q&A is complete.
Okay, just a quick note. If you do use the little hand raising function, I may not see you because we have enough participants that I can't get you all on my screen at once. So if I don't see you, or if you just want to type it out, please go ahead and use the chat feature. And we've already got a couple of questions, so we'll dive right in. Is there a freight elevator? The answer is no. There are multiple person elevators, and each tower has a service elevator, but it's not a large freight elevator. It's a normal size elevator. Will you need a crane to reach the 21st floor? Unless you can break everything down into sizes that fit in the service elevator, I would say the answer is almost certainly yes. And do we have the actual building height? It's about 225 feet, give or take a few feet, depending on where you're measuring grade from.
And there's more detailed site information, like building height and specifics to the rooftop and electrical system in the site report that's included in our documentation.
We've been asked what kind of roof system will be used for the new roof. We've spoken to the condo board about this, and the assumption is they will stick with the existing style of roof, which is what they tend to call an inverted roof. You've got the membrane on the bottom with the insulation over it, and then ballast over the top of that. How do we access the internet? That's a good question, and one that we have not really dug into, but I don't suspect it'll be a significant challenge. We'll probably have to run an Ethernet cable through some of the service spaces in the basement to wherever their router is, which is most likely at the front desk. Is there a reason why our designs are in portrait/landscape?
No.
Yeah, I don't know which. I think they're all in landscape, but no. Is this a prevailing wage job? That's a no.
That is a no.
That's a no. Is the building sprinklered?
I don't think so. There is a standpipe and that runs through the building up through these towers. We'll check. So we'll compile all of these questions and issue more formal, maybe longer responses as well. And that's one that we will confirm.
Yeah, it's certainly not fully sprinklered. There may be certain mechanical spaces that are sprinklered.
Yeah, actually, I think it's just the parking garage. I don't think the building itself has a sprinkler system.
Next question is, how can we evaluate the roof structure? The batteries are very heavy, and siting on both the roof and courtyard will require a structural evaluation. That is true and correct. You'll want to bring in your own engineers to do the evaluation and design work for that. Our initial assessment is that you'll be able to tie into existing building steel and easily support the load, but of course the details are going to be up to you. Are drawings available?
There are building drawings available. They're in CAD format mostly, and those are included as a part of our site documentation. The drawings that we've done are basic helioscope designs. You can design it however you'd like, with whatever modules you'd like. So we don't have drawings available for that.
Next question, will we be able to perform a site visit in person? And if so, how and when?
Yes, you can visit the site in person. Just give us about a week to coordinate with the building. We'll be doing them on an individual basis, and you'll have to follow standard protocol with COVID.
Okay. Will there be a site visit? Yeah, we covered that. Please confirm that there will be 4 bid options submitted, 2 ESS sizes for each of 2 locations. Yes, I can confirm that. That is correct. And again, you'll have further detail in the RFP. What structural assessments of the 2 ESS locations have been completed? They've been preliminary assessments carried out by an architect. But as said earlier, to finalize your designs is going to be up to you, and you'll need your own engineers to plan that out. Where are the standpipes on the roof and courtyard located? The standpipes on the roof, I believe there's one in each tower in the stairwells, which are pretty much centrally located on each tower. As to a FDNY water supply to the courtyard, I do not know. I don't recall seeing one.
There isn't one there, but I think there's a fire hydrant pretty close by, either this structure or this structure right here. FDNY has also said that depending on exact placement, they might require a new standpipe run along the exterior of the building if it is going on the roof over here. If the one inside is insufficient.
The RFP says the ESS will not be charged by the grid. Is this a requirement, or could there be an option for grid withdrawal via building's existing Con Ed account?
So we specified in the design that we want an export-only CDG project under normal operations. And also for potentially collecting the ITC, we think it's important that it's pulling only from the PV system. So I believe we're pretty firm in sticking to an energy storage system that can only be charged by the PV. Is that right, guys?
Whatever maximizes the incentives. So we want to get the solar and storage ITC. We want to get as much of the property tax abatement as possible, which is both on the solar and storage side, the state income tax credit. So if you know a way to get more out of those tax credits, please propose that. But it's our understanding that you won't be able to charge from the grid and take the ITC. But there aren't many of these projects that have been done. So if you know something we don't, please propose it and just provide documentation that says that this can be done and is eligible for the incentive.
Yeah.
What are the elevator sizes? As the rails and mounting materials could be 21 feet, will the elevator hold a 10 foot or 14 foot? Or you're going to have to measure the elevators yourself during a site visit because I don't have the actual dimensions.
We can,
but consider, yeah, we can probably provide a little more detail on that. They're certainly not going to hold anything 21 feet.
Yeah, and on the site report on pages, on page 4, there's a very, we have a great condo board that's very involved in this, and they provided very detailed notes on access limitations. So with the doorways and other things that you'll have to interact with besides the elevators as well. So that might be more of a limiting factor than the elevator. Some of them have a height limit of 6 feet. Some of them have a width limit of 33 inches. So that's another useful reference point, and we'll definitely get the size of the elevators for you as well.
Is the roof structure visible, or will finished materials such as drywall need to be removed and put back in order to evaluate the roof or courtyard structures? The courtyard structure is it's a parking garage beneath the courtyard, partially. So that's going to be visible from below. As far as the roof itself, there are areas in which it is visible, particularly if they have mechanical spaces directly beneath the roof. But in a lot of these areas, the roof structure is not going to be clearly visible, and you may have to do some penetrations into there, which will need to be patched up. Okay, placing electrical equipment in the gas meter room is not permitted. Suspected that might be the case. And the hallway is not recommended and may cause egress issues. Are there other proposed locations for electrical equipment? The hallway seemed the prime one, mostly due to proximity and because it's an unusually wide hallway, so it depends in part on your equipment size. If another location needed to be found, there are other possibilities, although we have not really explored them deeply or documented them directly. But as of right now, the hallway seems sort of your prime candidate for an automatic transfer switch. Does the RFP stipulate kilowatt sizes, or is the contractor required to select the size to meet required critical loads? I believe we specified 200 kilowatts.
So we have guidelines, but you can provide, estimate or use whatever you'd like in determining what ESS size will work best for you. We know that there's a lot of limitations on sizing, especially for as off the shelf as large systems like this can be. So the goal is to, knowing that our baseline is around 2,000 kilowatt hours per day, having a 50% reduction and a 25% reduction approximately. It doesn't have to be those numbers exactly, but what we're trying to do is maximize their usage of elevators, maximize their usage of public area lights and charging. This building is one that was affected by Sandy, and it's one that will be affected by large storms like that again. But knowing that these are so infrequent and most of this system is going to be used for backup power, we need to also make it as economical as possible. So that's why we're using rough numbers to try to make something work here.
Okay. The interconnection for the CDG export account will be into Con Ed's Cooper Square network area. Is that correct? I don't have that answer off the top of my head. Derek?
I don't think we've looked into it at that level of detail.
Okay.
Yeah, I think that's something we can circle back on.
Okay. And there's a further question as to whether that's 4 to 8 o'clock CSRP network area.
So
but
that's a good question. It is exactly on the border, and we confirmed that's something else that I would like to confirm offline first. I believe that is the time window. It is right on the border between two different areas though. So it's worth confirming. But if you submit that in writing, we can give a written response.
Is the battery rating specified on the RFP a beginning of life number or an end of life number? Beginning? Is that fair to say?
We also have multiple numbers for describing nameplate and usable stored energy. Usable stored energy is obviously the more important number. But yes, that usable stored energy number is describes, on day one, what we expect USE to be. But, you know, durability of the battery, cycle life is an important factor, and we wouldn't want something that would, you know, significantly degrade with minor day-to-day operation within a couple of years. We want this to last as long as possible.
And what duration discharge should the rating be based on?
I think I mean, something around a 4-hour battery, right? I think the question is more energy than power, which is sort of why we focus less on power rating. So as long as it's a battery capable of 4 hours or less, that's probably a sufficiently powerful battery for our needs. And so then as long as you meet the energy requirements that we described, you know, 650 kilowatt hours or 1500 kilowatt hours roughly, then the battery should be good. But there's definitely flexibility there. You know, as long as it's not an extremely low power battery, we have come across some technologies that have a far lower C rate than that. So that could be a problem. We do want to make sure that we can meet peak load. And, you know, a thing to also bear in mind is weight, especially if you're looking at a rooftop system. You want to take into account both power ratings and, you know, the weight of the battery to meet those basic needs.
And another note on that, this storage system is also being designed as essentially a backup generator replacement. So you're trying to imitate that, knowing that you're never going to be able to provide as much power as a backup generator will, given the size of the common area loads, and not isolating any of them from that.
Okay. Can we get access to the energy usage data you have on common areas?
Yes.
Huh? Good. Good. And if somebody wants access to that, they should email us, correctly?
We will add it to our RFP documentation, which everybody will have a link to.
Okay. Has the building already completed an energy efficiency assessment to determine if the critical load can be reduced?
The building is doing a number of things to reduce the critical, the common area load. So that is also why we think this methodology works. So they're going to be installing more lighting controls. They're going to be installing more elevator controls. They're going to work over the next couple of years to try to make it as efficient as possible, especially in a blackout situation. So I'm not sure if it's an energy efficiency evaluation, as much as they're trying holistically to reduce load, meet local law requirements, and be as green as possible.
And they have already upgraded most of their common area lighting to LED, correct?
Yes.
Yep.
Yeah, and then as far as the loads that are powered during a backup situation, they're going to have some manual load shedding in order to manage their energy supply. And this is going to be carried out by the professional staff on site. Can we get contact information for the building's elevator contractor? I think we can provide that, yeah.
Yeah, we'll see what we can do with that one.
How many cycles per year for charge and discharge?
It's a hard question to answer definitively. Again, we're open to different proposals if you have a better idea than our concept design, but our basic assumption was that a relatively small portion of the battery, a couple hundred kilowatt hours maybe, would be set aside for VDER optimization under alternative 2 for capacity payments, which would mean the battery would be doing a small portion of the battery, a minority of its full energy rating, would be used for load shifting, but at least under alternative 2, that would be primarily during peak summer hours, so it wouldn't be every day. And not only would it not be every day year round, but it wouldn't be nearly the full energy rating of the battery. So we're talking about partial cycles, not daily. But that said, if you have a better idea for how to optimize meter or some other way to monetize the battery, we're all ears.
Okay. Energy varies depending on the time it takes to discharge it. 100 kilowatt hours at 4 hours does not equal 100 kilowatt hours at 2 hours. Yeah, that's true. And if you can get your battery manufacturer to provide more detailed data on that issue, I'd love it if you could share it with us. Yeah, it is just the case that this is the nature of things, and there's not always as much clarity as you want, and it's very difficult to assess battery performance ahead of time, depending on how long you want to take to discharge the battery and various C rates. So yeah, that just sort of, that is what it is. So follow the guidelines in the RFP. Does the building have a fire alarm? Yes, it does. It's alarmed with a central station, which is next to the doorman's desk in the lobby.
Here.
And of course, they're tied into FDNY. I assume all the Q&A will be typed up and sent to us, correct? Yes, I am currently seeking view control that creates a transcript of the chat and not finding it. So we are very much hoping to do so. But of course, we will take questions via email and share those answers with all of the respondents.
Yeah, so we will share all of his questions, even if we have to rewatch this and manually transcribe everything. But additionally, you can send questions as they come up to Derek. We have a question deadline that's later in August. I think it's about a week before RFP responses are due. We'll respond to questions as we receive them, but at that point, we'll publish all of the questions that we receive as well. So you'll have more insight into what everybody's thinking about.
Okay, oh, it looks like I missed a question too. Was it brought back up again? Asking if the far northeast corner was left out due to shading considerations. The primary reason it's left out is because it's, for the rooftop mounted option, this would be our prime area for the energy storage system. But yes, it also suffers from some shading issues on the southern section of the roof. Obviously, you can do your own helioscope or assessments or whatever tool you like to use. But the central section here is, I think, about 14 or 16 feet high. And this will also depend on the height of your array and whether you shoot for an east or a south orientation. But I think you could fit enough of an east-facing array on the northern end of that section to make it worth doing.
Yeah, and we've also done shade analyses for the different parts of these buildings, so, or the different parts of the rooftop. So our sun eye shade analysis is included in documentation. You can see what it looks like there. And one note on, Richard just reminded me, when you're talking about designing a system for this central portion here that's near the penthouses, you want this to be as minimally visible as possible. So you don't want something that has high tilt. You want it as close to the roof as possible, so you're not obstructing the views from these units up here.
Okay, I'm not seeing any more questions at the moment. I did find the option to save the chat log, so hooray. We'll give it a moment to see if anybody's typing.
And Derek, why don't you tell everybody about the network
You read my mind. I was about to say, so for previous meetings, we've had lots of requests to see the registration lists for the pre-bid meeting, which I believe we may be able to share in this case. Is that right? But in addition to that, and something that we think might actually be more useful is our vendor partnership network. You'll see that was linked in our initial email with the RFP. We will also link it in our follow-up email to this meeting. There you can just put in a couple details about your firm with contact information and what kind of services you provide. And then that information will populate on a spreadsheet where you will find everybody else who has offered their information. So that way you can make new contacts with firms that might be compatible with yours if you want to team up on a bid. So if you're a PV installer looking for a storage installer, that's a great place to look. Yep, so that's called the Vendor Partnership Network, and you'll see more details in our follow-up email.
Okay, we got two more, I guess three more questions came in. Does the building have an existing backup generator, and does the battery need to black start the generator, or does the system replace the existing generator? The answer is the third option. They do not have an existing generator. A lot of this started with them looking at installing one, and they didn't like the costs and some of the issues that come along with fuel supply, et cetera, for a generator. So they're really sort of forward technology thinking and wanted to look at using a battery instead. So there isn't a generator, and there's not going to be a generator. Since Black Start was mentioned, worth bringing up, and this is in the RFP, but the ESS should be able to black start the PV array, thus allowing it to recharge itself as much as possible during an extended blackout situation like what we saw after Hurricane Sandy, where they might be without power for days or weeks. And what is the best email phone contact if we have further questions?
Reach out to Derek. Email is derek@solar1.org. If you're calling him, please don't call him at 1 in the morning.
And that's solar1.org is the number 1, not spelled out.
You can reach out to me and Richard as well, but Derek is your primary contact for this RFP.
Okay, it looks like that's all we've got for questions. Angelica, did you want to open it up for introductions and card passing?
Yeah, if anybody wants to unmute yourself and start your video and introduce yourself, if you haven't already, you're welcome to do that. No, we can call it a day and stay in touch. I'm going to take that as a no. So thank you everybody for joining. Like we noted before, Derek will send out a follow-up email with some more materials. There will be a recording of this available, and please reach out with any questions, and we look forward to hearing from you soon. Thank you.
Yes, thank you for your time.